Okay, shall we start now? Hello.
Yes,
Hello. Okay, so good morning to all of you. Hope I am audible to everyone and you can see my screen. Hello.
जरा आवाज
हाँ, क्या हुआ?
एको एको
एको है।
सर
एको
आपका
तो नहीं,
आवाज कम आ रहा है।
आवाज कम आ रहा है। एक मिनट रुको। Hello. Now is it okay?
yes sir.
Just a moment. Okay. So hope you can see the screen. Okay. Good morning to all of you.
Good morning, sir.
Good morning. Now today we have lecture number 10. Okay. And from today we start our next new topic. Okay, that is a second part of the engineering mechanics. Okay, unit number 4.1, which is from dynamics part. Okay, so let me first just go through with the slides and let me introduce about the topic. Okay, so dynamics, basically what is dynamics? Okay, you already knowing the statics part. Okay, in engineering mechanics we have two branches, two sub branches. One is statics and another is a dynamics. Statics deals with the bodies which are at rest. Similarly, here dynamics is nothing but a branch of mechanics which is concerned with the analysis of particles as well as bodies which are in motion. Okay, this is very important. Motion. So with respect to this motion, we have two distinct branches in dynamics. One is called as a kinematics, okay, and another is a kinetics. Okay, this motion we are studying in two different ways. Okay, one is kinematics and kinematics. Kinetics. Am I audible to everyone? Hello.
Yes, sir.
Yes,
Yes, sir.
Yes.
Now kinematics is about what dealing with the motion parameters. Okay, what is the motion parameters like your displacement, velocity, acceleration, and time. But here the main thing is that whenever we are dealing with the motion parameters, okay, these motion parameters, okay, we don't consider here the effect of what the cause of motion, or we can say effect of the masses or force. Okay, effect of force. Are you getting me? So without the effect of forces, okay, that means we are not going to deal with the relationship between these motion parameters and effect of forces. We are going to only study the geometry of motion. That is only the motion parameters. We are not going to deal with the cause of the motion. Motion कैसे हो रहा है? Okay. So that is what that branch is called as a kinematics branch, okay, of the dynamics, okay. Then kinetics. In kinetics, what we do, we actually, it is the branch of dynamics used to predict the motion caused by the given forces. let's say you have this block. Okay, let's say this is having 5 kg block, and if you are applying, okay, a force. Okay, so what will be happening to the motion parameters due to these forces? We are going to determine the what relationship between the motion parameters and forces, and sometimes we are what expected to determine the forces which are required to produce a given motion. So in all, we want to say that here we are going to consider the cause of motion as well. Okay, in addition to the motion. Okay, so is it clear to you? Kinematics and kinetics. Next is when we consider the study of the dynamics. Okay, so we have two different idealization. One is a particle and another is a rigid body. Okay, now what does the particle means? Particle actually is nothing but, let's say I have this you can say, let's say यहाँ पे एक एरोप्लेन है. Okay, ये let's say एक एरोप्लेन है. Okay, ये फ्लाई हो रहा है. Okay, स्काई में, ठीक है, एंड आई वांट टू स्टडी द मोशन, मींस आई वांट टू एनालाइज इट. ओके, तो आई कैन एनालाइज इट इन टू डिफरेंट एस्पेक्ट्स. one aspect is that I can analyze it by treating it as a body with negligible dimensions. So here I mean that this particular assumptions hold true if this this particular assumption will hold true if the shape and size of this aeroplane will not affect the motion parameters. Okay, and that particular assumptions or that particular idealization is nothing but referred as a particle. The particle is basically a body with negligible dimensions. Okay, so physically a body may have very large dimensions, but लाइक मैंने यहाँ पे एरोप्लेन का एग्जांपल दिया, तो फिजिकली इसका डायमेंशंस है, लार्ज कंसिडरेबल है, बट these dimensions are insignificant for a particular type of motion, and then only this assumption will hold true. Okay, so that is what particle, that comes under particle. So the study of the particle can be in two different ways, like kinematics and kinetics. तो जब kinematics बोलेंगे तो kinematics of particle होता है. It is what kinematics of particle. Kinematics of particle. Similarly, we can have kinetics of particle, right? Are you getting me? Hello. So when we are saying that kinematics of particle, so kinematics of particle means what? We are going to analyze the particle, but only considering the geometry of the motion. We are not considering the cause of the motion. And when we say kinetics of particle, that means we will consider the motion as well as the cause of the motion, which are affecting the particle. Is it clear to you? हेलो, पार्टिकल क्या है समझ में आया?
Second,
काइनेमेटिक्स. हाँ, यस. हेलो.
I didn't get that second point. Can you explain it again?
Which second point? Second point says that if you have some body, let's say, okay, it may have some physical dimensions, okay, in actual reality case, but these real dimensions we can neglect it for our simplicity, okay, for our simplification. Suppose अभी यहाँ पे एक ब्लॉक रखा है मैंने, ओके, जिसका डायमेंशन कुछ तो होगा, कंसिडरेबल डायमेंशन होगा, 500 बाय 1000 कुछ भी हो सकता है, ठीक है. But for our simplicity, we can neglect this dimension. I can treat it as a point, and I can say that its dimensions are negligible, so that this point can be easily analyzed. Okay, the motion parameter with respect to these points can be easily analyzed. Are you getting me? So
Yes.
that particular thing will be true only if this, if I am treating this as a point, and this point ट्रीट करने की वजह से उसके मोशन पैरामीटर्स पे कुछ इफेक्ट नहीं आएगा, लाइक वेलोसिटी, डिस्प्लेसमेंट वगैरह कुछ इफेक्ट नहीं होगा, इफेक्टेड नहीं होगा.
Okay, got it.
Hello.
Hello, am I audible now? Hello.
Yes, sir.
Yes, sir.
हाँ, बीच में थोड़ा ये हो गया था, सिस्टम कुछ प्रॉब्लम है यहाँ पे नेटवर्क का थोड़ा सा. ओके, तो आई होप आई एम ऑडिबल नाउ. तो सिमिलरली यू अंडरस्टूड द पार्टिकल ना. सिमिलरली यहाँ पे वी हैव assumptions राइट रिजिड बॉडी. ओके, तो इन केस ऑफ रिजिड बॉडी व्हाट हैपेंस. हाँ, जैसे मैंने बोला बॉडी विथ नेग्लिजिबल डायमेंशंस, सिमिलरली हियर इट इज रिवर्स. ओके, पार्टिकल. तो बॉडी रिजिड बॉडी के केस में वी कैन हैव व्हाट वी कैन कंसीडर डायमेंशंस एज यूजुअल. जो है बॉडी वैसे ही लेके कंसीडर करके एनालाइज करेंगे. बट देयर विल बी ओनली वन assumption दैट इट विल बी comprising of infinite number of particles and whose relative positions remain unchanged under the action of forces. Means ये जो बॉडी है इट विल बी मेड अप ऑफ नंबर ऑफ पार्टिकल्स, वी ऑल नो. ओके, एंड दिस पार्टिकल्स अगर इस पे फोर्स अप्लाई किया तो ड्यू टू द एक्शन ऑफ दिस फोर्सेस द पार्टिकल्स का पोजीशन इज नॉट गोइंग टू चेंज सो मच. ओके, इट विल बी नेग्लिजिबल चेंज. दैट इज व्हाट we can say angular displacement of these all particles will remain same almost. If you measure this angular displacement, then only this body can be what treated as a rigid body. तो rigid body का वही मतलब होता है जिसका relative positions हर एक particle का जिससे वो बना हुआ है that remains same. Okay, so here in all we can say in case of the this rigid body assumptions, angular displacement and angular velocity, angular accelerations all are same. Okay, so you can consider the particle ideation as well as to analyze the motion. You can consider the rigid body ideations. Okay, similarly we can have kinematics of rigid body. Okay, kinematics of rigid body, and we can have kinetics of rigid body. Okay, तो kinetics of rigid body आपके syllabus में नहीं है. Okay, now you tell me what is the motion of this rigid body considering the only motion parameters. Okay, and what we are neglecting the cause of the motion. In case of kinetics of rigid body means of rigid body and what as well as the cause of motions. Is it clear to you? What is actually the kinetics, what is particle, rigid body? Okay, these all things should be clear to you. Okay, ये clear हुआ सबको? Hello.
Sir,
हाँ,
it's
sir.
Sir,
like
can you please explain the last part? Kinematics of rigid body. Your voice was cracking.
Yes, your voice
Okay.
is low.
Voice is क्या? Cracking. Crack हो रहा है? एक मिनट रुको. Now is it okay now? Hello.
Yes, sir.
हाँ, तो इसमें क्या है, काइनेमेटिक्स ऑफ रिजिड बॉडी मींस व्हाट. काइनेमेटिक्स मतलब हमको पता है ना, हमने काइनेमेटिक्स मतलब क्या होता है. काइनेमेटिक्स में सिर्फ मोशन पैरामीटर्स आएंगे, मोशन एनालिसिस विदाउट द कॉज ऑफ मोशन. कॉज ऑफ मोशन क्या होगा, निग्लेक्ट होगा, यानी फोर्सेस यहाँ पे निग्लेक्ट होगा. फोर्स वी आर नॉट गोइंग टू कंसीडर. And rigid body means what we are going to consider the what size and shape of the body as. Okay, and that body has to be rigid. That means it's what relative positions of all the particles, okay, from which it is made up are what same. Okay, or it is negligible. That means we can say angular displacement theta, omega, and angular acceleration of the particles are same. Is it clear to you? The rigid body का analysis, okay, the rigid body analysis without considering the cause of motion is referred as kinematics of rigid body. Is it clear to you? Hello, hello.
Yeah, sir, you're audible, sir.
Now next is a frame of reference. Okay, we all know that motion is always measured with respect to the certain point. Okay, so that point, reference point or datum point, is that point against which the motion is measured. Okay, so how to select a reference point? There is no any hard and fast rule. We can select any frame of reference. Okay, basically we are working in Newtonian reference of frame. Okay, where the Newton law holds true. Okay, so a convenient way to fix up the frame of reference is we are choosing the three mutual perpendicular axes. Let's say this x, this y, and this z. And we are what we are going to measure the coordinates of all the particles under that frame of reference, and if we can say if that particular coordinate x, y, and z remains same with respect to time, then we can say it is a rest. And if it is changing, let's say it was x, y, z at t, then it becomes x1, y1, z1 at t1. Okay, x2, y2, z2 at t2. So then we can say these are changing with respect to time, and it is not a static, it is a dynamic coordinate. Okay, it is a dynamic one. So that is what the way, okay, how we select the frame of reference. This all you must be knowing, I think, in your physics course you might be taught. Okay, so this is clear to you. Hello. Next one is now we are saying that what motion. ठीक है. Hello. तो बेसिकली हमको ये पता चला कि डायनामिक्स में हमको क्या करना है, मोशन के साथ खेलना है. ठीक है, मीन्स वी आर गोइंग टू what entirely work on this motion. Okay, on hello, am I audible ना? So
Yes, sir.
Yes, sir.
and in our course we have a planar motion. Okay, we have a planar motions, yani motions which are lying in a plane. So what are the different types of motion possible in a plane? That first we are going to see. Let's see what are the different types of motion in a plane. The first one is a translational motion. Okay, that is a translation motion. You all know what is translation. Translation motion is what the motion which are in a with, can you define translation motion? The motion in which the particles of the body remains parallel to each other during the entire motion. Okay, means all the particles of the body move along a identical parallel path. ठीक है, तो लेट्स से ऐसा है, अगर ये पार्टिकल थ्रू आउट ऐसे ही रहेगा स्ट्रेट, मीन्स इट विल फॉलो अ पैरेलल पाथ. ये दूसरा अगर मैंने स्ट्रीम कंसीडर किया तो दिस विल बी parallel, this relative position of all the particles will be parallel to each other. Okay, then all the particles of the body will have same displacement. Okay, now this motion are further classified into two subcategories. One is called a rectilinear motion. Okay, that is 1D translation. Okay, and another is called a curvilinear motion. Okay, that is 2D translation. See, अभी ये translation motion है, तो translation motion may be possible in a, see the path which follow the body follows some path, no, during the motion. So this path may be a straight path, right? This path may be a straight path, or this path may be a curved path, right? So when it is a straight path, when the body follows a straight path, like for example, if you have a car, okay, it is moving on a road. Okay, it is moving on a road with certain velocity, a straight road. Okay, this is a straight road. So this is what is exactly following the straight path. So that's why this motion is what translational, but it is following a straight path. That's why it is a translational motion of rectilinear type. Okay, that is 1D translation. Similarly, if the paths are curved paths, okay, let's say like this, okay, but they are always parallel to each other. Okay, let's say car is moving on this curved path, okay, with certain velocity. Okay, so this is what a curved path. Can you see? Hello. So the body is following a curved path. Again, it is a translational motion. Okay, because along this path, okay, along this path, it will be always parallel. So there will be identical parallel path. Okay, have a same displacement along this path. Okay, so that is again a translation motion, but it is a curvilinear motion. Okay, and why it is called 2D translation? Because when it is moving on a curved path, okay, it will have simultaneously movement in x direction as well as in y directions. Okay, तो इसका जो डिस्प्लेसमेंट होगा x and y direction both may be possible at a time. That's why it will need a two coordinate systems to analyze. That is a curvilinear motion. Okay, so in the first half part we are going to study the rectilinear motion, and in the second half part we are going to study the curvilinear motion. Is it clear to you? Hello.
Yes, sir.
Second type of motion which is possible is a rotational motion. Okay, rotation motion means what? All the particles of the body move in a circular paths. Very simple. Okay, like for example, अगर मैं rotation motion का बात करूँ तो you all know already the fan. Okay, ceiling fan सबने देखा होगा. The blades of fan. So the blades of fan performs what? rotation motion. No? So that is a simple example for rotation. Okay, if you know the gears, okay, gears आपने देखा होगा, okay, sugar cane machine में आपने देखा होगा gear system. They are what always in contact. Okay, they may be either external mesh or internal mesh. They are rotating. Okay, one is rotating like this, the another is rotating like this, opposite to that. That is what rotation motion. So in rotation motion, all the particles of the body have different displacement. These are the what characteristics of the rotational motions. Because here the shape and size comes into picture. Okay, अगर suppose एक body इतना बड़ा है, दूसरा body इतना बड़ा है, ठीक है, तो that will giving the different scenario. Okay. Then third type of motion which is possible is a general plane motion. Okay, what is general plane motion? Now see, the motion which we define is a pure translational motion, and here we define pure rotation. But it is possible that some motions may not be pure translations, and some motions may not be pure rotations. So what will be happening in this case? So that type of motions comes under this category. That means it will not be a pure translation, it will not be pure rotation. That is called a general translation. So here, if I give you example, vehicles रहता है उसके wheels जो रहते हैं रोड पे, ठीक, जब vehicles move होता है slip नहीं होता है ना, so that vehicles का wheel is what moving without slipping condition. That means it is what ये vehicles है, ये vehicles का wheel है, this wheel is what actually it is rotating as well as performing the translation motion. And simultaneously it is giving the rotation motion plus translation. क्योंकि देखो ये रोटेट भी होता है और आगे भी बढ़ता है ना, गाड़ी आगे भी जाते हैं, ठीक है, तो दैट्स व्हाई व्हीकल का व्हील जो होता है मोशन व्हीकल व्हील मोशन विदाउट स्लिपिंग व्हाट गिविंग राइज टू जनरल प्लेन मोशन. तो जनरल प्लेन मोशन में क्या होता है, द बॉडी ट्रांसलेट्स एंड रोटेट्स साइमल्टेनियसली. ओके, and all the particles of the body will move in a different path. फिर आप उसके हर एक पार्टिकल को ट्रेस करोगे, समझ में आया, हर एक पार्टिकल को ट्रेस करोगे तो it will follow the different paths. Okay, we'll see that when we study the kinematics of rigid body, that is general plane motion analysis. Okay, so in our syllabus we have this and this. Okay, is this understood? Is it clear to you? The different types of motions and the characteristics of different types of motions. Okay, so this is very important. First, you should understand the different types of motion before analyzing the motion parameters. Now, next is we will start with the rectilinear motion first part. Okay, here. So today we will discuss the first part, that is a rectilinear motion. Okay. Now, this rectilinear motion already I have defined. What is rectilinear motion? The motion of particle along a straight line. Along a straight line. So whatever the motions we are going to consider here, that will be along a straight line, and therefore it will be a 1D analysis. Okay, so it will be simple. So in 1D analysis, if we are considering any motion parameters, let's say displacement, acceleration, velocity, whatever these parameters, okay, we all know these are vector quantities, right? Displacement is also vector, velocity is also vector, acceleration is also vector. These all quantity will need a vectorial or vectorial addition or subtractions. Okay, vectorial addition or subtractions लगेगा. अगर उसको analyze करना है, it will need a vectorial treatment. Okay, for analyzing these parameters. Okay, so but since we are considering here the rectilinear motions and this is a 1D, in case of 1D, this can be algebraically analyzed. Okay, in 1D, it doesn't matter whether we are considering vector addition or not. In case of 1D analysis, algebraic addition subtractions may be performed on a each motion parameter, so it doesn't matter. Okay, so we are going to do same here. Now, rectilinear motions of a particle can be further classified as what? See, whenever we are going to consider a body, okay, let's say car का example जो मैंने लिया था, कार है, okay, it is moving on a straight road, okay, with some velocity, okay. Now this is rectilinear motions, but these rectilinear motions may be possible in three different scenarios. Okay, this body may have a same velocity throughout during its motion. Okay, it may have same acceleration throughout, right? It may have a different acceleration, means variable acceleration, right? So when it is having a same velocity throughout, this is referred as rectilinear motion with uniform velocity, or it is called a uniform motion. Or uniform motions. Here, the velocity will remain same throughout the motion of the body. Velocity will remain constant, same, not zero. Okay, constant, and hence the acceleration of the particle will be zero. Are you getting it? Hello.
Yes, sir.
Ah. Now, we all know for rectilinear motion with uniform motion. Okay, तो इसको analyze करना है अगर, तो we have what for rectilinear motion with uniform motion, we will have some equations of motion. Okay. So since we know that where acceleration is zero and body is moving with uniform velocity. Okay, uniform velocity means what? Velocity is same throughout. Okay, so it is constant, and we know that velocity is what? Rate of change of the displacement. Okay, so simply अगर हमको velocity calculate करना है यहाँ पे, तो velocity is what? S by t. ठीक है, that means displacement per unit time. We are going to see what is actually the velocity displacement in the further slides. We define that first. So here simple equations which will be used for rectilinear motion with velocity analysis. So that is equal to as the we all know. Okay. Since displacement is same to velocity, the displacement may or may not be same. See, this is the very important thing. But velocity will remain constant. Okay, so that's why we have to adjust this parameter such that this should be a uniform motion. So for analyzing this kind of motions, we have equation P is equal to S by. Second motion which is possible is rectilinear motion with uniform accelerations. As I told you, acceleration will remain same. That means constant throughout. Okay, uniform acceleration. Okay. So in those cases we can say acceleration will remain constant. Okay. So for that, let's say कोई body है, it is moving with 2 meter per second square. So it is not variable. This acceleration is not going to change with respect to time. It will remain 2 meter per second square throughout the motion. That is what acceleration constant is. It will not be a function of let's say t or function of s or function of velocity like that. It will not be variable. Okay, it will not change with respect to time. That is what the constant acceleration motion is, or uniform acceleration motion. So these types of motions may be analyzed with respect to the three equations of motion, and that you already have studied, I think, right? ठीक है ना, आपने physics में पढ़ा हुआ है ना? There is a relation between v. Okay, see there are three parameters v s sorry s v a, and then one is a common one t, time. It can be correlated with all. Okay, so when you have to relate the v and a, you can relate with respect to u plus at. That is the first equation of motion. Second, when you want to relate what s and a, you can use this. S is equal to ut plus half at square. ठीक है, ये आपको सबको पता होगा ना. C, third equation. When you want to relate what v and s, then you have v square is equal to u square plus 2as. Okay, remember here v is what final velocity of the object or the body. U is the initial velocity. A is the acceleration of the body. That is uniform acceleration. Okay, that is a constant acceleration, and t is what time. Here time is a what scalar quantity. Okay, rest all are vector quantities v u a. Okay, so that will need a vectorial treatment. But here, as I already told, this is 1D analysis. So here vectorial neglect किया तो भी चलेगा. Okay, direct addition and subtraction is possible. That is algebraic addition. Okay. Then here s is what displacement. Remember s is what vector quantity. That is displacement. That may be positive or negative. Okay, displacement may be positive or negative. We are going to see what is the difference between distance and displacement. Then again here, what t is what again scalar quantity. Okay, a and u are vector quantities. Okay, so I hope it is clear to you. Okay. Third equation is what rectilinear motion with variable acceleration. With variable. Variable means what? Acceleration will not be constant throughout the motion. Okay, it will be function of time, or it may be function of velocity, it may be function of displacement. Okay, so here we are going to use some another equations which will be true for all cases, whether the body is under uniform motion or not. Let's say dv by dt. Okay, a is equal to what? Let's say we can also write there is a relation. If you want to relate a and v, so if a is a function of v, then you can write a as dv by dt. If a is a function of s, you can write v times dv by ds. Okay, so likewise you can have these equations. Okay, which you can use for variable accelerations. So where the case of variable acceleration is there, we are going to use this equation, and this is valid for all cases. Valid for all cases where acceleration is not constant. And these are the equations. This is applicable only for where acceleration is not constant. Is it clear to you? So these all are the possible types of motions under rectilinear motion. Okay, and when the body is now, the main thing is that here, these rectilinear motions may take place in horizontal plane as well as in vertical plane. So horizontal का जैसे मैंने example दिया आपको ये car is moving in a straight road, but it is in horizontal way. ना? So this is what motion is taking place in a horizontal plane. Okay. Similarly, another example if I will give you that person walking on a road, ship moving in a water. These are all rectilinear motion which are taking place in a horizontal. Similarly, we can have a rectilinear motion which is possible in vertical plane as well. Let's say, for example, if this is a tower, and at the top of the tower there is a boy, okay, standing there, okay, and he is dropping some stone from the top of the tower. तो मैं बोला ये जो स्टोन है ग्राउंड पे कितने टाइम में रीच होगा. ठीक है, that is what the body is. It is dropped from the top of the tower. It is performing again a rectilinear motion, but it is what in the vertical plane under the gravity. So that is what kind of the rectilinear motion on the vertical plane. So ball similarly यहाँ पे suppose ground पे एक boy खड़ा है, okay, and he is what throwing a ball up in the sky. So that is again what performing a rectilinear motion under the gravity, and that is due to the gravitational field. So this is again a rectilinear motion, only rectilinear motion, okay, but under the gravity. Okay, are you getting it? The rectilinear motion may be possible in horizontal as well as vertical plane. Okay, यहाँ तक clear है? Hello.
हाँ सर.
Now there are some important terms in a rectilinear motions. Okay, position. What do you mean by positions? Okay, can you define the positions? You all might be knowing what is the positions. You should understand this um, very specifically. Okay, because these terms will come in problem. So if I have to define the position, what is position? Position is nothing but what? Actually, it is nothing but an exact location of a particle along a straight line. But if we have to what locate the particle with respect locate the particle exactly along a straight line. तो let's say मैंने अभी ये जो रोड है इस पे मेरा कार मूव हो रहा है, ठीक है. Now I want to locate it actually exact location अभी इसका क्या है, इसका positions क्या है. So I need some reference point or you need some origin. So that is what data which decides the position of the particle. So that particle can be located with respect to this what reference point. Let's say this is a origin. So I can say this is at x position. Okay, x may be let's say 5 meter or something. Okay, तो मैं बोल सकता हूँ कि this particle is at x is equal to 5 meter or something. So this may be possible in positive. This may be positive. Okay. Similarly, it may be negative. Okay, if it is to the left of the origin. If it is right of the origin, so it is positive. Similarly, car यहाँ पे है. Okay. Now I am measuring like this. So it is what left to the origin. So that's why it will be negative. X will be negative. So I can say what is the position of the particle right now. Okay, and it is a vector quantity. Is it clear to you? Now next is what? Displacement. What is the displacement? Displacement is what? Let's say अभी मैंने यहाँ पे बताया आपको, जैसे मान लो एक मैं ऐसा यही एग्जांपल ले लो, ठीक है, ये ओरिजिन है और ये आपका y और ये x, ये आपका कार है सपोज, ठीक है।
Sir,
हाँ, यस,
sir, your mic voice is not clear.
नाउ इज इट क्लियर? हेलो हेलो,
No, sir.
हाँ सर, बराबर है।
बराबर है ना? आपकी साइड से चेक करो, बाकी लोगों
हेलो।
को हाँ, यस,
Ah, yes, sir.
हाँ सर।
माय वॉइस इज कमिंग टू यू ना? हेलो,
Yeah, sir.
यस सर।
yes, yeah. So now let's say this car is having at this location, okay, so this is what x1, let's say, and now it has to reach here. This is what final position, let's say, this is what final position, let's say x2, इसको यहाँ तक आना है। okay, तो यहाँ तक आने के लिए इसको, it is starting position, okay, initial positions, and it is a final positions, okay, it may follow some path, okay, it may have some routes, okay, it may go through different routes, okay, but what will be the shortest route? That is the shortest distance, okay, that shortest, what, shortest, you can say shortest distance or shortest route between the initial, shortest distance between the initial position and final position of a particle is nothing but a displacement, okay. So here the displacement will be the final position minus initial position, right? This simple एकदम बोलिए तो shortest path, shortest distance, okay. For example, अगर suppose मैंने ये ऐसा एक आपको एक particle दिया, okay, let's say the particle moves from A to B first, okay, this is what A, coordinate 0 0, let's say this is B, okay, let's say this is C, okay, this is 5 0, let's say, and this is 4 meter, let's say, this is 3 meter, ये path का length 4 meter है और ये path का length 3 meter है। Let's say particle moves from A to B first and then B to C, then B to C. So tell me what will be the displacement here? Hello, are you getting me? Can you tell me what will be the, yeah, displacement will be the shortest distance between the initial position and final position. This is here initial position and it has to reach finally at C, so it is a final position. तो ये A to B जाके फिर B to C भी आ सकता है, बट शॉर्टेस्ट वाला कौन सा है? ये वाला A to C। तो आपको डिस्प्लेसमेंट के वक्त हमेशा इनिशियल और फाइनल पोजीशन देखना है, बाकी कुछ नहीं देखना। तो A to C will be the final and that will be 5, right? Are we getting me?
Yes, sir.
Sir.
Next is a distance. Distance is what? See, displacement जो था, displacement का वैल्यू पॉजिटिव नेगेटिव दोनों भी हो सकता है, पॉजिटिव और नेगेटिव दोनों भी हो सकता है, बिकॉज इट नीड्स अ मैग्नीट्यूड एज वेल एज डायरेक्शन। हम ये भी देख रहे थे कि बॉडी कौन से डायरेक्शन में जा रहा है। अगर सपोज ये बॉडी यहाँ से यहाँ जा रहा है, इट विल बी पॉजिटिव, यहाँ से यहाँ आ रहा है तो इट विल बी नेगेटिव। दैट मैटर्स हियर, दैट इज डिस्प्लेसमेंट वैल्यू मे बी पॉजिटिव एंड नेगेटिव डिपेंडिंग ऑन द मोमेंट ऑफ द बॉडी। समझ में आया ना? तो यहाँ पे जो डिस्प्लेसमेंट है, इट इज अ वेक्टर क्वांटिटी, but distance is what is scalar. So in case of distance, it doesn't matter whether the body is moving in positive x direction or negative x direction. So distance is actually the actual distance or actual path which is covered by the moving particle or body in a given interval of time. अभी यहाँ पे यही एग्जांपल मैंने लिया, तो इसमें डिस्प्लेसमेंट के तो मैंने बता दिया। What will be the distance here? Can you tell me? हेलो हेलो डिस्टेंस इज व्हाट एक्चुअल length कवर्ड बाय द पार्टिकल। तो पहले पार्टिकल क्या कर रहा है a to b जा रहा है। a to b how much is the distance covered that will come into picture। then it is moving from b to c। okay तो b to c भी जा रहा है। b to c how much is the distance covered that will also come into picture and you will add this। so that will be giving you the 4 plus 3 that will be 7 meter। that is what your called as a distance। distance is what scalar quantity। तो distance जो है उसको लेना देना नहीं है डायरेक्शन से। वो टोटल डिस्टेंस बताएगा, टोटल लेंथ बताएगा पाथ का कितना कवर कर। आर यू गेटिंग? हेलो तो कैन यू टेल मी
Yes, sir.
अगर पहला चीज तो आपको ये क्लियर हो गया डिस्प्लेसमेंट डिपेंड्स ऑन इनिशियल एंड फाइनल पोजीशन ऑफ द पार्टिकल। सेकंड ये भी क्लियर हो गया कि डिस्प्लेसमेंट वैल्यू में भी पॉजिटिव और नेगेटिव। नाउ वन थिंग यू कैन नोट हियर, अगर आप देखो ध्यान से तो अगर मैं बोलूँ कि पार्टिकल इज मूविंग अलोंग a straight line in one direction or you can say unidirection and if there is no change in the direction of the motion of the particle मतलब let's say अगर एक मिनट होल्ड करो।
Hello. Hello, sir. Sir, you are muted.
हाँ भाई सर ने होल्ड करना।
Leave.
हेलो
हेलो हेलो
यस सर।
हाँ आवाज आ रहा है ना?
नहीं आ रहा था पहले।
हाँ अभी आ रहा है ना?
हाँ सर अभी आ रहा है।
अभी
हाँ
आ रहा है अभी आ रहा है।
तो आज जो 11:30 का आपका लेक्चर है ना, सेजल मैडम का फोन था, ये शी इज नॉट गोइंग टू टेक। आई विल टेक द मैकेनिक्स का लेक्चर इन दैट स्लॉट। ओके तो आई विल शेड्यूल आफ्टर दिस लेक्चर एंड देन यू कैन जॉइन एट
सर
11:30।
मैथ्स का एक्सटेंड
सर
हुआ
अभी
है।
सब
मैथ्स का हो
मैथ्स
गया।
का
हाँ
लेक्चर है।
सर सूर्यकांत सर से बात कर लो एक बार।
नहीं अभी नहीं है। 11:30 को जो सेजल मैडम का लेक्चर है वो दैट।
हाँ
बारह
सर
बजे
सर वो
तक
मैथ्स
बैठ
लेक्चर
के
12 बजे तक शेड्यूल किया।
आज सर ने 3 बजे
हाँ
तक लिया।
सर वो सूर्यकांत सर ने किया तो सर वो शेड्यूल।
नहीं वो सेजल मैडम तो बोल रहे हैं, अभी देखते फिर बाद में डिस्कस करेंगे। चलो जाने दो। ओके मैं सेजल मैडम से बात करता हूँ एंड विल लेट यू नो। ओके
हाँ सेजल मैम नहीं लेने वाले थे बट सूर्यकांत सर एक्स्ट्रा लेने वाले थे ऐसे सर ने बोला।
मैथ्स के सर ने 10:20 से 12 तक किया है एक्सटेंड।
हाँ 12 या 2 था ना, 2 बजे तक ऐसा कुछ था।
2 नहीं रे भाई, 12।
Okay, let's forget that. Sejal madam has told me to take her lecture in 11:30 wala slot. So I will discuss with her once, okay, and will let you know. Now,
हाँ
please
सर ले लो
close that.
सर, एक दो डाउट भी था सम्स में, ले लो सर।
हाँ, तो अपना जो है वो कंटिन्यूएशन में चला जाएगा तो ठीक रहेगा, ठीक है। आई विल लेट यू नो, ओके। अकॉर्डिंगली आई विल शेड्यूल, ओके। अगर नहीं शेड्यूल किया तो मत ज्वाइन करो, शेड्यूल किया तो ज्वाइन कर लेना, ठीक है। ओके, तो प्लीज क्लोज
ओके
दैट टॉपिक। हाँ, तो ये समझ में आया ना डिस्प्लेसमेंट एंड डिस्टेंस का कंसेप्ट आपको, ओके। तो मैं क्या बता रहा था आपको, हेलो। हाँ, इफ द पार्टिकल इज मूविंग इन अ सिंगल डायरेक्शन एंड इट इज नॉट चेंजिंग इट्स व्हाट डायरेक्शन, ओके। हेलो, मैं ऑडिबल ना?
यस
मेरे पास एक क्वेश्चन है आपके लिए, वो मुझे आप बताओ, ठीक है, अगर समझा है तो। मैं क्या बोल रहा हूँ यहाँ पे, सी फर्स्ट क्वेश्चन इज दैट कि इफ द पार्टिकल इज मूविंग अलोंग अ स्ट्रेट लाइन, ओके, एंड इट इज नॉट चेंजिंग इट्स डायरेक्शन, ओके, मतलब वो जो मूव कर रहा है वो एक ही डायरेक्शन में मूव कर रहा है, आगे जाके वो ऐसा टर्न नहीं करता है बॉडी, ठीक है, रिटर्न नहीं आता है यहाँ से ऐसे वापस, सिर्फ वो स्ट्रेट लाइन फॉलो कर रहा है पाथ, ओके, इट इज यूनिडायरेक्शनल मोशन। इन दैट केस टेल मी, मतलब ये एग्जांपल नंबर 1 जो था, इस केस में displacement and distance, okay, will be having the same value, can I say? Hello?
सर
Yes.
इक्वल होगा।
Yeah.
सर
In that case, displacement and distance will be same, right ना? Because that is not changing its direction. तो till the time जब ये change करेगा तभी ये displacement और distance क्या होगा, अलग अलग होगा, otherwise it will remain same. Because that point पे जाके फिर ये जब direction change करेगा तो यहाँ पे इसका velocity भी क्या होगा, ये वेलोसिटी जीरो होता है इस पॉइंट पे, ओके, तब वो जाके वहां से अपना डायरेक्शन बदलता है। विल सी दैट व्हेन वी अनालाइज, ओके। तो यहाँ पे क्या होगा कि डिस्प्लेसमेंट एंड डिस्टेंस विल बी इक्वल until the particle is not changing its direction, okay। Next thing is that displacement और displacement में क्या रिलेशन हो सकता है इन जनरल, कैन आई से डिस्प्लेसमेंट, देखो अभी यहाँ पे डिस्प्लेसमेंट और डिस्टेंस में ये से अगर यूनि डायरेक्शन है तो दैट विल बी इक्वल, बट सपोज यूनि डायरेक्शन नहीं है, सपोज ये वाला एग्जांपल दे दो, दूसरा वाला, तो इस केस में मैं बोल सकता हूँ क्या, डिस्प्लेसमेंट विल ऑलवेज बी लेस देन और इक्वल टू डिस्टेंस इन जनरल मैं बोल सकता हूँ क्या ये, बिकॉज डिस्प्लेसमेंट का वैल्यू कांट एक्सीड डिस्टेंस ना। हेलो, displacement will always be less than distance because distance is what the total distance covered and displacement is what the shortest distance covered. That's why displacement will always be less than or it will be maximum equal to the distance. So this you have to take in mind, okay, right?
Yes.
Yes, sir.
Now I have again one question for you, okay। अभी ये डिस्प्लेसमेंट और डिस्टेंस के ऊपर और एक क्वेश्चन है मेरे पास, ठीक है, वो आप सॉल्व करो, वो कैसे करोगे अभी, ठीक है। लेट्स से नाउ ये हो गया आपका जो है, एक मिनट, नाउ लेट्स से आपका जो है, फॉर एग्जांपल कैन यू हियर मी ना?
Yes, sir.
Yes, sir.
Yes, sir.
अभी
ऑडियो
आपने
आ रहा है।
हाँ, अभी आपने स्ट्रेट पाथ फॉलो किया, स्ट्रेट ट्रैक फॉलो किया, ठीक है। लेट्स से द पार्टिकल, ओके, लेट्स से आई हैव समथिंग लाइक दिस, ओके, ये सेमी सर्कुलर पाथ है, ठीक है, ऑफ रेडियस r, let's say of radius r, okay, and let's say there is one particle, this is a particle a, okay, this is a particle a, and it is what covering the semicircular path. So what will be the displacement here? Means a particle which is moving on a semicircular path of radius r, you have to tell me what will be the displacement and distance here. No,
Displacement will be r, distance
2
will
R
be
and 5 R.
हाँ, डिस्प्लेसमेंट क्या होगा,
radius.
okay, how many of you are saying 2r,
Distance
all
2
are
R.
saying 2r, and distance कितना रहेगा,
5 R.
Pi R.
Pi r.
pi r.
Distance
Okay.
by 2.
Okay. Similarly, let's say I have a circle. What will be the answer?
0 and 2 pi r.
पूरा पूरा ये जो पार्टिकल है ना पूरा सर्कल कवर कर रहा है, ठीक है।
हाँ 0 0
डिस्प्लेसमेंट कितना रहेगा आपका यहाँ पे?
डिस्प्लेसमेंट 0
0. That's very good. Distance?
Distance 2 pi r.
2 pi r.
2 pi circle.
pi r. Very good. ये कैसे पता चला आपको? Because see, displacement 0 क्यों हो गया? Because particle, let's say this is initial position and this is what? This is initial position. Particle started from here and started moving like this. Again, it is coming back to the initial position only, जहाँ से start किया. So whenever particle starts from the initial position and comes back to the initial position, in that case displacement will be always 0 because वो क्या होता है? Same position पे आ जा रहा है, ठीक है? यहाँ पे क्या हो रहा था? Particle started from here and coming here. Okay. Then this covers what? This arc, ना? This semicircular arc. So it is equal to what? अगर मैं शॉर्टेस्ट डिस्टेंस देखूंगा तो यहाँ पे ये इनिशियल और ये फाइनल पोजीशन हो गया, तो ये मेरा ये हो गया शॉर्टेस्ट डिस्टेंस, दैट इज 2r सिंपली। तो डिस्प्लेसमेंट हो गया 2r। और अगर मैं डिस्टेंस मेजर करना चाहूँ तो मुझे ये आर्क जो है सेमी सर्कुलर आर्क का लेंथ निकालना पड़ेगा, दैट विल बी पाई r सिंपली। सिमिलरली यहाँ पे डिस्टेंस इज व्हाट डिस्टेंस ऑफ दिस arc, that is what the circumference of this circle, that is 2 pi r. Okay, it is clear to you? Hello. But now let's say, again I have one question. Let's say this is a circle. Okay, are you getting me? Hello. This is a
Yes.
center of circle. Okay.
Yes.
Now let's say instead of I have one particle. Okay, let's say that particle covers theta. उसका जो एंगुलर डिस्प्लेसमेंट है थीटा है, वो पूरा कवर नहीं कर रहा है, सिर्फ इतना ही कवर कर रहा है। कितना कवर कर रहा है? सिर्फ इतना ही कवर कर रहा है, यहाँ से यहाँ तक। लेट्स से दिस इज ए, दिस इज बी, सिर्फ ए से बी तक कवर कर रहा है, ए से बी तक जा रहा है। द पार्टिकल इज व्हाट कवरिंग दिस ए बी राउट, दिस ए बी डिस्टेंस। इस केस में मुझे बताओ डिस्टेंस और डिस्प्लेसमेंट कैसे निकालोगे?
Sir, distance so 2 pi r into theta by 2 pi.
Just tell me what will be the value here?
Distance r theta.
Distance क्या हो जाएगा? Simply distance will be the length of this arc, ना? Length of this arc, that is r into theta. And theta, always remember, this will be radian. Okay, theta will be always in radian. Okay, radian में होगा. Okay, for example, अगर ये यहाँ पे एक सर्कल है, ठीक है, और ये यहाँ पे मैंने सेम एग्जांपल ये है, ये ए बी, लेट्स से दिस इज व्हाट ये 60 डिग्री, ओके 60 डिग्री। तो यहाँ पे दिस इज डिस्टेंस, ओके डिस्टेंस इज लेंथ ऑफ आर्क। तो डिस्टेंस विल बी व्हाट? डिस्टेंस विल बी r into theta. Theta is what? 60 degree, ना? Theta is 60 degree. Hello. So this will be in radian.
Yes.
R into 60 degree means pi by 3. जो भी वैल्यू आएगा that is pi r by 3. So this is what distance covered by the particle. Now what will be the displacement? अगर आपको ये
2
जनरल
r sin of theta by 2.
yes ये आप निकाल सकते हो by geometry. Okay, I think that is not a point to discuss here. ये आपको एग्जाम में प्रूव करने को नहीं पूछेगा, just you have to remember. In this case you will have some standard formula, that is 2r sin theta by 2. So as per here, यहाँ पे आप इसको अप्लाई करोगे तो you will get displacement as how much? Yes, displacement will be 2r
sin theta by 2.
60 sin 30 degree, that is 2r into half, that is r, right? So this is your answer. So remember, whenever you are asked to find the displacement and distance, you have to what use this logic always, okay, for a circular path. अभी ये आप यहाँ पे भी अप्लाई करके देख सकते हो. थीटा इज व्हाट हियर, थीटा इज पाई ना, राइट और नॉट.
Yes, sir.
तो यहाँ पे आपका जो डिस्टेंस आ जाएगा दैट इज आर थीटा, दैट इज पाई आर, and displacement is 2r sin theta by 2, that is sin 90. 90 is 1, so this is simply 2r. Similarly here, theta is what? Theta is 2 pi here, right? So 2 to cancel, sin pi will be 0 and displacement will be 0. And here r theta, that is 2 pi r. So this is what the general case. This I discussed, that is general case. This you can keep in mind, okay? Is it clear to you now?
Yes, sir.
Displacement and distance clear हो गया ना सबको? Now the next thing is what average speed. Okay, what is average speed? Can anybody?
Total distance by total time.
Yes, average speed. See, speed जब भी आता है ना, तो speed is always related to what distance, because speed is what magnitude of the velocity. That is a scalar quantity. Are you getting me?
Yes, sir.
Am I audible?
Yes, sir, you're audible.
Yes, sir.
Yes, sir.
The speed is what? Speed is nothing but here. You can write in general. एक minute. Average speed is equal to the what distance upon total distance upon time. Okay. Suppose if the particle is what in the previous example जो मैंने ये triangle वाला लिया था यहाँ पे, okay, that was what A, B and C. This was 4 meter, this was 3 meter, and it was 5. Let's say particle takes what if a particle takes 2 seconds to move from A to B. Okay, A to B जाने के लिए उसको 2 seconds लगता है, और B to C जाने के लिए उसको, or you can see B to C जाने के लिए उसको let's say it takes 3 seconds. So can you tell me what is the average speed? Yes, the distance total for 4 plus 3 by time interval, that is 2 by 3, that is 7 by 5, that is 1.4 meter per second. Similarly, the average velocity. Average velocity क्या होगा? Velocity is what? Vector quantity that is related to the displacement. So that is displacement per unit time. Okay. So if I say here to find out the average velocity, that is average velocity, that is vector quantity, तो vector attach किया यहाँ पे, तो कितना हो जाएगा? Can you tell me? Yes. Hello.
5 by 5. 1.
5 by 5.
That is 1 meter per second, because we have this is a displacement. Okay, so I hope this is very clear to you. So it is what in particular time interval, that is delta t. यहाँ पे delta t क्या था? ये था 2 to 3. Okay, delta t was 2 to 3, that is t1 plus t2 here. Okay. Now I can have this as average values. I can have instantaneous values also. What does instantaneous value means? Instantaneous value means at a particular instant. अगर ये मैं delta t थोड़ा थोड़ा reduce करते जाऊंगा, here is a zero. This time interval, if I take as a in mathematical way, I say that delta t tends to 0 such that it becomes a particular instant. Let's say t1, t2. Okay, now I can have the value of speed and velocity at a particular instant, and that is known as instantaneous values. So let's say मैंने बोला आपको find out the speed. Okay, find out the speed at 3 seconds. Okay, that is what instantaneous value of the speed. Find out the velocity at 3 seconds. That is what instantaneous value. Are you getting me? So instantaneous speed is nothing but what limit of delta t tends to 0, that is delta s by delta t. Okay, and that is nothing but ds by dt. Clear to you? Similarly, you have the instantaneous velocity as limit delta t tends to 0, delta s bar upon delta t, that is ds bar by dt. Are you getting me? Hello?
Yes, sir.
So in similar fashion, you can define average acceleration. Average acceleration will be what? The average speed upon the time interval. Okay. And similarly, you can have instantaneous acceleration, that is acceleration at particular instant of time. Let's say acceleration at 2 seconds, 3 seconds, 4 seconds, right? Acceleration is what? Rate of change of velocity. Correct, no? Am I clear to you?
Yes.
And the last one is a jerk. What is jerk? Jerk is nothing but the rate of change of acceleration. Okay, that is dA by dt. Okay? So this you should know. These are the important terms which we are going to consider in rectilinear motion, and we are going to analyze through the different cases one by one. First, we will consider the motion with uniform velocity and uniform acceleration, and then we will consider the motion due to the gravitational action under gravity. And we will see the examples. We will solve that analytically, and what, then we'll analyze it using a graphs, that is a motion graphs. Okay, so we'll see in the subsequent lectures. Okay,
Sir,
clear to you? Any
uh,
doubts?
no,
Yes.
sir, if we have doubts in that assignment that one you gave, what should we do?
असाइनमेंट में डाउट है तो यू कैन आस्क मी ना, अगर आपको डाउट है तो आप पूछो मुझे. ओके, आई विल गिव यू द हिंट, बट सॉल्यूशंस अभी नहीं दूंगा क्योंकि सॉल्यूशंस कैन नॉट बी डिस्कस्ड राइट नाउ. यू हैव टू सॉल्व विद योर ओन. सॉल्यूशंस विल बी डिस्कस्ड लेटर. ओके
सर, कैन यू प्लीज प्रोवाइड आंसर की फॉर क्वेश्चन
आंसर
बैंक
की
एंड
मैंने दिया है, आंसर की मैंने दिया है ऑलरेडी इसमें.
नहीं सर, हमें नहीं मिला.
अरे मैंने इसमें दिया ना आपको, कुंज को दिया था. अच्छा, आपके इसमें नहीं है क्या कुंज? अच्छा, हु इज द सीआर इन योर क्लास?
Yes sir, I am, and Krisha.
हाँ, तो उसको मुझे
Yes,
टेक्स्ट
sir.
करने
Me also.
उसको. हाँ, तो you text me, I will forward you and you can forward to the class. Okay.
Okay, sir.
Okay. Is it clear to you? Any doubts?
सर अगर लेक्चर बाद में एक्सटेंड
Sir, actually,
कर रहे तो बस एक बार.
हाँ, वो पता चल जाएगा ना. मीटिंग शेड्यूल किया अगर तो आपको अटेंड करना है, नहीं मीटिंग शेड्यूल किया तो नहीं
Sir,
करना.
should I text you on Meet, because I mean on Teams, because I don't have your WhatsApp number.
हाँ, you can text me on Teams तो भी चल. WhatsApp पे किया तो मैं डायरेक्ट फॉरवर्ड कर दूंगा ना. ठीक है.
सर नंबर नहीं है.
नंबर ठीक है, नंबर नहीं है तो मैं आपको यदि आपका अटेंडेंस हैज बीन रिकॉर्डेड. ठीक है जय, यू कैन
सर एक
टेक्स्ट मी. हाँ, यस
सर असाइनमेंट की क्वेश्चन नंबर 2 में मोमेंट कहाँ से कैलकुलेट करना है वो मेंशन नहीं किया क्वेश्चन में, तो फिर वो डाउट था बहुत लोगों को.
अच्छा ठीक है, मैंने अटेंडेंस ले लिया है. जिसको जाना है वो जा सकता है, जिसको कुछ क्वेरी है वो रुको. ठीक है. यस, यू हैव द मीटिंग. हाँ बोलो, क्या है डाउट्स? हेलो
सर असाइनमेंट की क्वेश्चन नंबर 2 में एक बोट वाला वो जो क्वेश्चन है, हल ऑफ द शिप, उसमें मोमेंट कहाँ से कैलकुलेट करना है वो मेंशन नहीं किया था.
अच्छा, वो रिजल्टेंट का बात कर रहे हैं. रिजल्टेंट्स मैडम ने पढ़ा है ना, उनसे डिस्कस कर लो आप. ठीक है, अभी उन्होंने क्या लिया है, कैसे लिया है, जरा उनसे डिस्कस कर लो. ठीक है, तो शी विल हेल्प यू. ओके, हेलो.
ओके सर, या गॉट इट.
सर बट उनका भी क्लास ही नहीं रहता है.
हाँ, उनका क्लास होगा ना, मेरा क्लास होने के बाद होगा. अभी टॉपिक वाइज वी आर गोइंग ना. अभी टर्म टेस्ट 1 में जो पोर्शन है पहले उसके हिसाब से जाना पड़ेगा ना. तो
But do you
whatever
know the
topics,
process for term test one?
still it is not officially declared. When it will come, I will let you know. Okay?
Okay.
You can assume whatever I am teaching, that will all be the part of the term test only. Okay, तो ऐसा मत समझो वो term test में नहीं आएगा.
Okay.
Okay, so you may leave the meeting if you are not having any doubt. Okay, thank you.
Okay. Thank you.
Sir, if there is a term test, how early can we get to know about it?